What do you mean progress? Welcome to lesson 3 of the Fibonacci. Yeah, America. Sorry, the world. The internet has. Yes, everyone is there. There's people in Africa and China and Antarctica. They're all watching. Okay. Okay. So we had the familiar Fibonacci sequence. We had the familiar Fibonacci sequence where you start with, the 0 and the 1, and we get the next term, 1, 2, 3, 5, 8, 13, etc. And those are denoted F0, F1, F2, F3, F4. The way I memorize this is F5 is 5. And then that's F6 and F7, etc., 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 stuff like that. But that's if we started with a 0 and 1. What if we started with any other two numbers? How about A and B? So if we started with an A and a B, and we did the same thing. The next number would be adding the previous two to get the next one, we would get A plus B. And so this is G naught. The first term is given to be A, and the second term, G1, is given to be B. And we can find G2 by just adding up those two. Now let's find more terms. I add the B plus the A plus B, I get A plus 2Bs, right? So we get A plus 2B, and that would be G3. And then if we add A plus B plus A plus 2B, how many A's do we get? We get 2 A's and 3 B's. So 2 A's plus 3 B's, and that's what we're going to call G sub 4. G sub 5, we add the previous two terms. If I add those two terms, we get 3 A's and 5 B's. So 3 A's plus 5 B's, that's what we're going to call G5. Let's just do one more for shits and giggles. Oh wait, sorry, we're recording, we can't say shits. For poops and giggles, we add up the previous two terms. We have how many A's? We have 5 A's. How many B's? We have 8 B's. So 5 A's plus 8 B's, and that is what we call G6. Now, it's no surprise probably that you're probably recognizing that the numbers next to the A's and B's, those are Fibonacci numbers. Like, what the heck? What are they doing there? Like this number 5 over here, this number 5 here is F5. I know that because F5 is 5. That's the one I have memorized for sure. And this number 8 here is F6. So what we can conclude is that G6 appears to be F5 times A plus F6 times B, and we note that A is G naught and B is G1. So we could predict G6 just by knowing Fibonacci number F5 and Fibonacci F6 and the very first two initial terms in the Fibonacci sequence. Did I say Fibonacci yet? Oh, I didn't say that yet. Okay, generalized Fibonacci. Some people call this Fibonacci, and they think they're funny and clever. I agree with them, actually. It's a pretty cute term. Generalized Fibonacci. So what can we garner from this? Can we find a closed form in general for Gn? What Gn appears to be, so that was a 6, and then we have F5. So maybe the next number is F with a one subscript lower than n, which is n minus 1, times G naught plus, so we have a 6 here under the G and a 6 here under the F, so it would stand to reason that there would be an n, Fn here, times the second initial condition, which is G1. So this is the magic closed form for the n plus first Fibonacci number. Given that you know the Fibonacci sequence, you can find the closed form of any sequence that starts with any two terms. So this is why Fibonacci, another reason Fibonacci is cool. No matter what two numbers we start with, Fibonacci sequence is involved. in the following sense that we see Fn minus one and Fn. So that is cool. Kendra, you said you agree. Wow, you're really into this. This is rocking your world. Amazing. Okay, if I can just reach one, it's worth it. The rest of you, to hell yeah. All right. No, not really. Oh shit, America's watching. The world is watching. Okay, when I say to hell with you, I mean to, did I say hell? I meant Jello. To Jello with you. Everyone likes Jello.
As long as you don't have more than 4 swear words for 20 seconds.
Oh, you should be fine?
Yes.
Okay.
I'll be right
Dane has a question. What is Dane's question?
back. My sister.
Okay, your sister doesn't like Jello. Okay, so that's a counterexample to everyone likes Jello. So we will have to extinguish said sister. Oh. What? When I say, did I say extinguish? I meant distinguish. This is awesome, sister. Distinguish. Okay.
Let her know.
Okay. Let us start with concrete, not A and B. Let's start with 3 and 1. So we have a 3 and a 1 as my G naught and G1. What's the next number? 3 plus 1 is 4. That's G2. And 1 plus 4 is 5. Hey, this is like pi almost. Isn't that cool? And then 4 plus 5 is 9. So that's G4. And then 5 plus 9 is 13. Wait, am I adding correctly? No, 14. And white out. I got white out. Okay. Newsflash, 9 plus 5 is no longer 13. The President of the United States has declared that it is 14. Okay, there we go.
What about the rest of the world?
It doesn't matter. America creates arithmetic. Okay.
That's why we use
9 plus 14 is 23. We're just having a ball here. Isn't this the greatest? This is the greatest. Okay, say I wanted to know G6, but I didn't want to know G4 and G5. Well, we have closed form. Yay! This is a closed form. So for G6, it would simply be G6 is equal to F6 times the first initial condition, G naught, plus n minus 1. I have another typo. This is all Dane's sister's fault. Not Jello hating sisters. Okay, this is a 5. And now the next subscript, so I don't want to be in charge of mistakes. So what's the next subscript? Using our closed form?
N.
Yes, N is,
The subscript?
yes, what is the number?
Oh,
Here is N. That's N.
6?
Yes!
Okay. Plus-
No, I didn't want any blessings, so I fought the sneeze away. I'm a true sinner. I can't have be blessed. I will burst into flames. Okay. Yay.
You looking into the light?
Okay, so we know F5 because that's 5. We know G naught because that's given to be 3. We know F1, F6 because that is the number 8. So 8. And we know G1, that's given to be 1, the other initial condition. And so we took this all together. We get 15 plus 8, which is 23. Yay! So this is a way to get at the 7th Fibonacci term without calculating the previous terms. Of course, you do need to know F5 and F6 in order to do this. So, in homework, if you're asked to find the 17th term of something, you can write them all out, which is hellaciously long, or you can just say G17 is F times F sub 16 times G naught plus F17 times G1. You know, that's the point of the closed form, to simplify your life so you don't have to find all the terms beforehand. Okay, let's do one more sequence that starts now. Instead of with 3 and 1, we're going to start with 7 and -2. So 7 and -2. Okay, so we start with a 7, and then we have a -2. So that's our G naught and G1. The next term is 7 plus -2, which is positive 5. Next term is -2 plus 5, which is positive 3. 5 plus 3 is 8. 3 plus 8 is 11. 8 plus 11 is 19. We're going to stop because that's where G6 is. 2, G3, G4, G5, G6. Again, if I was lazy and I didn't want to compute everything before in order to get G6, I would just plug it into the closed formula here and say G6 is F5 times G0 plus F6 times G1, just like the previous problem up here. So F5 is still the number 5, but now G0 is the number 7. And F6 is still number 8, and now G1 is the number -2. So we have 35 plus -16, which equals, it better be 19. Because if it's not 19, we don't get to do the boogie dance. The boogie dance is actually very important for the course. If you do not know how to do the boogie dance, your probability of passing the course dwindles by a margin of 102%.
That's fair.
Do the boogie dance, Ryan.
Good.
Okay. Okay. Okay, so we had a very serious question from a student. Here we go. Oh. Right. I've been training for years to get that down. I did my official training at the Pickle during Picklepalooza on the bar. Yes.
On the bar, I think.
On top of the bar.
I think correlation.
Okay. The Fibonacci matrix. This is where things are get really cool. Plus, the matrices are going to be on the exam, chapter 2. So let's recall how we multiplied two matrices. I just want to put this down. This, if we have like say the numbers 1, 2, 3, 4 times 5, 6, 7, 8. Recall that we have our left hand. Our left hand goes left to right, while our right hand.
Oh, this stuff again.
Yes, this stuff is coming back on the exam. Right hand goes top to bottom. So we have 1 times 5 plus 2 times 7 as our top left entry. Our next entry is 1 times 6 plus 2 times 8. Our next entry in the bottom row, we go to the bottom row of the left matrix, first column of the right matrix, 3 times 5 plus 4 times 7. And then lastly, 3 times 6 plus 4 times 8. This is ringing a bunch of bells to everyone. It better be. No, happy bells. Yes, happy bells. Who? Wedding bells. Mazel tov. We're all got married just now. Okay. So, and of course, we would add them all up and get some numbers, but I'm not going to do that because the reality that I might make a mistake is threatening. Okay. So this is the Fibonacci matrix. Notice the bottom left, bottom right entry is F0. In the anti-diagonal, we have the same terms, F1 and F1. And then in the top left, we have F2. So let's square this. If we square this, we have 1, 1, 1, 0 times 1, 1, 1, 0. If we do the math, we have 1 times 1 plus 1 times 1. So the top left entry is 1 plus 1, which is 2. Top right entry is 1 times 1 plus 1 times 0. So in other words, 1 plus 0, which is 1. The bottom left entry is 1 times 1 plus 0 times 1. So that's 1 plus 0, which is 1. And the bottom right is 1 times 1 plus 0 times 0. So that's also 1. Cool. Let's cube the matrix Q. The fast thing to do is not to write 3 matrices, but just to say Q cubed is Q squared times Q. We do it that way because we already computed Q squared. Q squared is 2, 1, 1, 1. And then up here, our Q matrix is 1, 1, 1, 0. So we do the matrix multiplication. We have 2 times 1 plus 1 times 1. 2 plus 1 is 3. 2 times 1 plus 1 times 0. So 2 plus 0 is 2. Bottom left entry is 1 times 1 plus 1 times 1. So 1 plus 1 is 2. And the bottom right is 1 times 1 plus 1 times 0. In other words, it's 1. Let's take it to the 4th power. By the way, there's an extremely a point to this in case you're wondering, what is the damn point? Q to the 4th is just Q cubed Q. We computed Q cubed already, this thing here. So we rewrite that. as 3, 2, 2, 1, and multiplying it by our original Q matrix, 1, 1, 1, 0. And we get 3 times 1 plus 2 times 1. So 3 plus 2 is this entry. The far right entry is 3 times 1 plus 2 times 0, which is just 3 plus 0. So we get a 3. Down here, we get 2 times 1 plus 1 plus 1. So this is 2 plus 1, which is also 3. And we're probably seeing a pattern here. 2 times 1 plus 1 times 0 is just 2. And what is the pattern so far? When we look at up here, we have, these are F values. Let's start with the bottom one we just had, because F5 is 5. We know that. F5, sorry. And the Fibonacci number 3 is F4. So that's on the anti-diagonal. And then the Fibonacci 2 is F3. So notice we have an exponent of 4 here, and we have subscripts that say 4 here and 4 there. Is that an accident? Probably not. Let's look at the one above. This one is F4, F4, F3, F3, and F2. So we see that we have a subscript that say 3, and this exponent here that's also 3. So same thing happens here. The exponent is 2, and in the anti-diagonal I have F2 and F2. And below it I have one subscript less. Above it I have one subscript more. So it looks like we're getting a pattern. Well, we're definitely getting a pattern. Let's do one last one, Q5. Q to the 5th is the same as Q to the 4th times Q. Q to the 4th we just figured out is 5, 3, 3, 2. And Q to the 1st is our original matrix, 1, 0. So we get 8, 5, 5, and 3. You know, I didn't even do the math anymore. I just know that it's the next Fibonacci number, and I know the 5s, that the exponent is 5, so the 5s go into that. I'm just, you know, I'm not doing the math anymore because the pattern is quite effervescently clear. So we have F4s in the bottom, F5s in the anti-diagonal, and F6 up top. So we need a conjecture, because you know what? That's what we're all about. Q to the nth power is a 2 by 2 matrix, and what are the damn entries? And what's the top left entry?
Fn plus 1.
N plus 1, yes. Because in this example, we see a 5 here. And then this number is a 6. So it's one more than the exponent is in the top left. So we have Fn plus 1. And then in our anti-diagonals, what is the 2 subscripts? N sounds clear, says the man whose sister hates Jello. And the bottom right subscript? All right. Cool. This is a closed form for the nth Fibonacci number. We just take this little tiny matrix and raise it to the nth power, and then the anti-diagonal, I get a closed form. So now we have 2 closed forms for Fibonacci. We have the closed form given by the Binet formula, and now we have the closed form given by this. And this is an easy thing a calculator can be programmed to do. And that's a way to get some, and also you get extra information. You don't just get Fn, you get the one before it and the number after it. So that's work the boogie gets. I'm gonna actually do the torque version. Okay. Sorry. I was in your space. Okay.
You might get a restricted hour.
Yes, I'll say that this is not for kids. There's a box to check. It's just
They
one
were
for
in
kids.
college, so.
I'll say.
Sure.
Okay, remember the determinant, fatty D, our buddy. If we have a matrix that looks like A, B, C, D, the determinant or fatty D is what times what, etc. Do you remember, Nick?
A times D minus B times C.
Memory of steel. Hmm?
Divided by 2.
Divided by 2?
Yeah, don't you do that?
Mhm. No. You were solid when you had this. You ripped this out of your memory, and this was 3 months ago when we learned this, so it's pretty groovy.
Or has
Okay.
already been 3 months.
Okay. Q, what is the determinant? Let's establish some notation. So that we don't have to write, we're gonna establish a notation, say dq to the n is the determinant or fatty D. Determinant of matrix Q to the n. Okay, so let's do the determinant of the first matrix. Fatty D of Q. Well, let's say, what is Q? This is the matrix, so 1 times 0 minus 1 times 1. So 1 times 0 minus 1 times 1. That's 0 minus 1, so that's -1. Yay, we got our first matrix. What about dq squared? dq squared. Oh, we need some information on q squared. Where is that? Q squared is this matrix here, so 2 times 1 minus 1 times 1. So this is 2 times 1 minus 1 times 1, which is also 2 minus 1, which is +1. Okay, we don't have enough data for a pattern, but let's see what the next determinant is. dq cubed. We look at this matrix, q cubed is this matrix, so 3 times 1 minus 2 times 2. So we get 3 minus 4, which is -1. Okay, we're back to -1. dq4 to the fourth power is 5 times 2 minus 3 times 3. 5 times 2 minus 3 times 3. So that's 10 minus 9. 10 minus 9 is +1. Does anyone see a pattern yet? It flippy floppies. Well, yes. Yes, it's switching gears every time. So dq to the 5, we expect this to be -1. Well, let's check. 8 times 3 minus 5 times 5. So 8 times 3 minus 5 times 5 is 24 minus 25. Holy woo-ha. This is better than Jello. All right. It's cool. So we need a conjecture, because that's what we do. The determinant or fatty D of the matrix Q to the n. Now, there's a bad way we can do this. We can say it's -1 when the exponent is odd. And it's +1 when the exponent is even. But that's a sentence. Can we find one single function that gives a -1 every time I feed it an odd number and a +1 every time I feed it an even number? Can we do that? This is worthy of my ultimate dance if you have this function. The one I've been working on for years and years with the Russian Ballet Academy. You didn't know that. 60 years of my life I dedicated. What you got? What you got, Catherine? Make me dance. Make me dance.
I don't have it.
Okay, you know your face? It was on the tip of your face.
I know it was. I was gonna say, n over n times -1, but that would. It would cancel out if the n was negative. Wait.
N times -1? Where's in? Okay, no, well, it almost works, but no, because these cancel out.
Yeah.
We want a function where like it's 1 every time I input something even. There's many different functions that do this. I just want one. Make my dance. Good. No, it makes it 1 only when the exponent is even. You gotta try cheesy?
Like maybe like f(2n minus 1).
f(2n minus 1).
Yeah.
This number is gonna get really big really fast. We want the number to only be 1 or -1. I'm gonna just throw something out and tell me what you think. When n is an even number, what is dq to the n, man? What is -1 to an even power? +1. What about when I take an odd exponent? This one works. This isn't the best and only answer, but this is a answer, and we're fine with a answer. So this is the conjecture. It works. And this is a fast way to compute the determinant of the matrix Q to the n. This actually has applications, sadly, in my research. When we were, it comes up. It comes up in an interesting way when you look at certain sequences. It's not just a weird fact, and it's not just something I want you to study for the exam, because you do have to know fatty Z for the exam. But this is like, it's a nice way to review this and also say, oh, that's kind of interesting, that the powers of Q always have a determinant of 1 or -1. Okay, so, what? Oh, no, no one gave the right answer, so I'm not doing the ultimate dance. Yeah, I'm gonna do it by myself, alone at home, in front of the mirror. Okay, I'll make a video. Okay, so when you find the Fibonacci sequence hidden, when people do air quotes, they're being sarcastic, it's not hiding, it's in your face, so blatantly. If we like, look at these slanty diagonals here. So the sum here of the number 1 is just 1. This sum is also 1, so because we didn't sum anything. Now this row gets interesting. The third slanty diagonal is 1 plus 1, which is 2. The next slanty diagonal is 1 plus 2, which gives us 3. The next slanty diagonal gives us 1 plus 3 plus 1, which is 5. Fibonacci is not trying to hide in Pascal triangle. 1 plus 4 plus 3 is 5 plus 3, which is 8. So far we got F1 from the row n equal 1, F2 from the row, the slanty diagonal, that's the second slanty diagonal. We got F3 from the third slanty diagonal, F4 from the fourth, F5, F6. And so we're getting like F5, here it comes from the fifth slanty diagonal. So this is kind of cool. The next one better be 13, is it? 1 plus 5 plus 6 plus 1 is 13, which is F7. And then 1 plus, that's F7. How many more am I gonna do? Maybe I'll just stop. Okay, that's it. We're gonna get the Fibonacci numbers. So it's not hiding in Pascal's triangle, it is in your face. So what is exercise 20? Consider the formula below this formula. Wow. F sub n is blah. This is the slanted diagonal. But now the important thing is to know, when do I stop? I go 0, 1, 2, then I stop at J. What the hell is J? Well, there's this thing called the floor function. The floor function. So for example, I'm going to give some examples and you tell me what you think the floor function is doing. The floor function of pi is 3. The floor function of 1.6 is 1. The floor function of 17 and a half is 17. The floor function of 6.166. What do we think the floor function is doing? It rounds down. Totally. It rounds down to the nearest integer. Hence the floor. If we turn these symbols upside down, we get the ceiling function, which has applications in other areas of math. But we want the floor here. So for example, if n equals 8, 8 minus 1 divided by 2, 8 minus 1 divided by 2 is 7 halves. So 7 halves is 3.5. So the floor function is 3. It rounds down to 3. So we're going to verify this formula for n equals 8. We were hoping to get this column here, the n equals 8 column, which is this one. 1, 6, 10, 4. And we're hoping that this is going to be F8, which is 21. That's what we're hoping to get. Okay, so let's look at this thing. J is 3, so we stop at 3. So we go 0, 1, 2, etc., all the way up to 3 at the bottom here. So F8 is, well, if n is 8, 7 minus 1 is, sorry, 8 minus 1 is 7, choose 0, and then 8 minus 2 is 6, so with 6, choose 1, n minus 3, oh, sorry, my bad. N minus 3 is 8 minus 3, which is 5, choose 2, and then finally I stop when the bottom number is j. In this case, when bottom number is 3, that's our j, so we stop. The top numbers are obviously descending, 7, 6, 5, last one is 4. Okay, so we go to Pascal's triangle, and we see that 7 choose 0 is the number 1, 6 choose 1 is the number 6, 5 choose 2 is the number 10, and 4 choose 3 is the number 4. If we add up these 4 numbers, we get. Yes. So now we have a third closed form for the nth Fibonacci number, Fn. So we have three forms. We have the Q matrix, we have the Binet form, and then now we have this one using Pascal's triangle, which is pretty cool. And there's zillions of more ways to get Fn, but I'm stopping at those three. And I believe your homework has something similar to this, but it's for the Luca sequence, for you to develop some conjecture. Okay. Second to last page, more hiding in the triangle. Again, it's super not hiding. Let's go to the fourth row here. And I'm going to multiply left to right these 1, 2, 3, 4, 5 numbers with F0, which is 0, F1, F2, F3, etc. So we're taking 0 times 1, that's the 0 here. And then to that, I'm going to add, now I take the 1 here, 1 times 4. And then I'm going to take the next Fibonacci number, which is 1, so I do 1 times 6. And then we do 2 times 4. And then we do 3 times 1. If we add up these numbers, we get 0 plus 4 plus 6 plus 8 plus 3. Which equals 21. And that's a Fibonacci number also, 21. Well, which Fibonacci number? We go back to our table. F8. So this is F8. F8 appeared from summing the fourth row of Pascal's triangle and multiplying it left to right with Fibonacci numbers. So this is row 4. Row 4 is weighted sum. This is called a weighted sum when we attach weights, Fibonacci weights on each number by multiplication. We get F8 from the fourth row. From the fifth row, what do we expect? Maybe F10. That would be reasonable because 8 is double 4. So maybe the next row will be double 5. So on row 5, if we do the math, weighting this with 0, 1, 1, 2, 3 times 5, and lastly the fifth Fibonacci number 5, 5 times 1. So in red we have the Fibonacci weights attached to the fifth row of Pascal's triangle, and if we do the math carefully without making a mistake, 0 plus 5 plus 10 plus 20 plus 20 plus 15 plus 5. Okay, again, we're hoping this is going to be F10. Is it? I can't read my handwriting. What is this? 10, that's a 10 plus. Oh yeah, is it 55? You did the math?
Yeah, 15 plus 5 is 20 plus the other 20 is 40 plus 10 is 15 plus that last 5.
Word. You should be an accountant to yeah, that's great. That's wonderful. And this is F10? Well, remember in the beginning I said the number is divisible by 5 and the Fibonacci sequence has subscripts that are divisible by 5. So this is F10. So we have a conjecture time now. That was the fifth. Whoa. Wait, hold on. I have to tell America in the world. I am a man, but my voice just broke. What is man? You know, just chill. Everyone just like, I'm proud to say I'm whatever it is I am.
Yeah. 3.
Okay. All right. So conjecture time, conjecture time. This is so with the numbers here, we have the numbers 0, 1, 1, etc. The Fibonacci numbers there. And then I'm looking at the nth row of Pascal's triangle, n 2 0, n 2 1, n 2 2. So what is the conjecture that this thing equals? We saw it here. Row 5, weighted, it equaled, and I summed them up, weighted with the Fibonacci numbers, gave us F10. The fourth row gave us F8. The nth row is going to give us n times 2. Yes, the subscript is double the row number. So this is a fourth closed form, but sadly, it's only for the Fibonacci numbers whose subscripts are even. So it's not a good closed form unless all you care about is subscripts that are even. So this is how the love story ends, but it doesn't end there. Every good story ends with tragedy. Okay. Well, this is not tragedy. Let's look at some history first. Fibonacci lived a shit ton ago. It's 1240, it's born in the Republic of Pisa. We call that Italy. Now his name is not Fibonacci. It's short for Latin Filius Bonacci. The FI means Filius means son of Bonacci. This is the plural of Bonaccio, which is his actual last name. Whereas his dad's name is Guglielmo Bonaccio. So why do we call it Fibonacci? Well, we concatenated Phi with Bonacci. And actually, who did that? It wasn't this guy, Leonardo. It was the subject guy. Edouard Lucas. Edouard Lucas was born substantially later than Fibonacci, but this is the person who's responsible for everyone knowing the extent of the beauty of the Fibonacci sequence, because he, well, he just wrote an amazing work in this time, and I still read his paper for inspiration and joy, and also for it makes me do the boogie dance every time I even think about his paper. Okay, so he died in unusual circumstances, not making this shit up. Can't, it's just too weird to be made up. At a banquet, a waiter dropped some crockery and a piece of broken plate cut Lucas on the cheek. He died a few days later of severe skin inflammation, probably caused by sepsis. He was 49 years old, and 49 is neither a Fibonacci number nor a Lucas number. So that was the real tragedy. I mean, this bugger should have died at the age of 55. But no, that's not even his sequence. That's Fibonacci's. He should have died at, oh man, he missed it by 2 years. Oh well. So you might wonder, what was on the plate? I'm guessing, judging by the year, it was like a Big Mac. But this is France, so they don't, no. Oh no, that's a quarter pounder. Sorry, Royale with cheese, whatever, something. Something very good. You know, they don't have a quarter pounder. You saw that movie? Because they have a metric system there, so there's no such thing as a quarter pounder. They call it Royale with cheese. There's some movie, I forget now. There's lots of guns, lots of death, lots of citing Bible verses before they shoot and kill people. What is that called? The movie?
Not Schindler's List.
No, it's Samuel Jackson, and he has a big gun.
Oh,
Pulp Fiction, yes.
yes.
Yes, Pulp Fiction. So, cool. And this was written by, again, this is the end of the party. This was made by Lou, Lou, say that, my friend. What do you say when I'm trying to refer to the curve? Sorry, that didn't happen. It wasn't a curve. Okay. Oh, your face happened. It's all good. We're besties forever, me and it's a set. We tried something. And yes. Goodbye. I'm not gonna, it's on video now. I love my bestie. Okay. Yes, that's it. You're capable of doing the homework next now. It's due on Tuesday, so you have way time, but I suggest you do it now.
Okay.
And see the play Cloud9. Apparently it's about identity stuff. Oh, I'm gonna see it on Saturday.
You have to, it's
I'm definitely gonna see it.
very good.
Wait, you're gonna see it Saturday? Why don't we go see it Sunday?
You're gonna see it Sunday? I'm gonna see it Sunday.
No, you should sit next.
How about-
That's what I'm saying.
Huh? Oh, Cloud9, are you playing that? People in the other class are in? Are you playing in the office?
Did I warn you?
It's raunchy, yes.
Okay.
I'm ready. No, I'm
I
super
just want
sensitive.
everyone to be a little bit prepared. It's not only raunchy, it's like unethical.
Oh, unethical. Oh,
Like it has potentially very triggering things, so I just. Costumes are great though. It's really.
Play Ride of America.
What is it about?
Yeah.
It's hard to explain, it's like a very, one of those really artsy plays that.
Say goodbye to the world.
But,
Everybody's
Bye, world. Have a good weekend, Abba.
The
Wearing shorts.
first act is placed.
I can't reach that.
Colonial Africa,
Okay.
So
and it
Fibonacci
surrounds,
can be
like, it
everywhere.
surrounds a British family.
Oh, wait, am I still, wait, what?
Fibonacci can be
And,
everywhere.
the second act, oh, also,
Yeah,
the roles are,
It was in your underwear, it's everywhere, it's under your hat.
my roommate is white.
Probably see you on the next Sunday then.
Okay.
And my friend Tanner is a big burly man.
Okay, stop recording. Goodbye.